Hello all, welcome back to this video on graph coloring problems. So what is graph coloring? So it is a process of assigning colors to the vertices of a graph. Assigning colors to vertices of graph. Okay. So that no two adjacent vertices share or have the same color. So I hope the concept is clear that what is graph coloring. It is the process of assigning colors to vertices of a graph so that no two adjacent vertices share the same color. Going through the definition, graph coloring is the process of assigning colors to the vertices of the graph such that no two adjacent vertices have the same color. So, what is the goal? The goal is to use the fewest colors possible. So, what is the goal? Is to use the fewest colors possible without any conflict is the constraint. Without any conflict is the constraint. Okay, what is the goal? Use the minimum number of colors possible to color the graph without any conflicts. Okay, so why does this matter? This problem appears in the real world scenario like scheduling exams where no two overlapping students take tests at the same time. Okay, so where is graph coloring used in real world is like scheduling exams where no two overlapping students take tests at the same time. Next, assigning registers in compilers. So assigning registers in compilers. Next, frequency planning in wireless network. Even coloring maps so no neighbor regions share the same color. So in map coloring, for example in Tableau, where we use graph coloring and no two countries should have the same color. No two countries should share the same color. That's the main agenda of graph coloring, is that coloring the vertices with minimum number of colors and no two adjacent vertices share the same color. Okay. Now, solving this is very tricky. It's an NP-complete problem. What is NP-complete? Non-deterministic polynomial time. Non-deterministic polynomial time. Non-deterministic polynomial time problem, which means that there is no quick solution for all cases. No quick solution for all the cases. So graph coloring algorithm comes under NP complete problem. As we have already said that NP complete problems don't have any particular or specific approach. One option is to backtrack or prune. So we can go ahead with backtracking in graph coloring algorithms. This is one of the effective approach. Okay. Now we'll look into how the algorithm works. We'll start by assigning a color to the first vertex. So in a graph, we'll start assigning color to the first vertex and then move to the next vertex and try the lowest numbered color. Next vertex V2 will check with the lowest numbered color, and that hasn't been used by its neighbors also. Okay, in the first step we'll assign a color to the first vertex. We have assigned a color, and moving to the next vertex we'll pick the lowest numbered color, and also we will cross check whether it is not used by neighbor vertices. Okay, if it is not used by neighbor vertices, and we will go ahead and we'll give that color, and if that is used by another neighbor vertices, we will backtrack it. Okay, if that is not used by another neighbor vertices, okay fine, we'll fix that color, but if it is used by neighbor vertices, we will backtrack or prune it. Okay, and we'll go with another lowest numbered color, next color. Okay, we'll change the color and try again. This continues till all the vertices are colored, successfully colored, or we determine that it's impossible with the given number of colors or given set of colors. Okay, so in the first step we'll assign color to the first vertex, and second step we'll pick the lowest numbered color and cross check if it is used by another vertices or not. If it is not used by another vertices, we'll fix the color, and if it is used by another vertices, we'll go ahead and we will pick another color, next set of color, so on until all the vertices are successfully colored, or we determine that it is impossible with the given set of colors. If it is not, if we cannot determine using the given set of colors, we'll stop the process. That's all explained in this pseudo code. Okay. So, key points. The key idea is to use eSafe function to check if a color works or not. If a color works or not. If a color works, we'll fix that and we'll commit and give it to true. If it does not work and used by neighbors, then we'll say to backtrack. Backtrack the color and go ahead with other colors. Okay. So here in this pseudo code you can see that we are using eSafe. That is whether we are checking whether it is used by the neighboring vertices or not. Okay. Based on the result, if it is used, we'll backtrack, or else we'll go for another color. So key points. The eSafe function is used to check if the current color assignment conflicts with the adjacent vertices or not. The algorithm tries colors in order. Okay. In given set of order. Backtracking when conflicts arise. So we have already chosen this. We have already gone through this. Backtracking is occurred when conflicts arise. The process can find a valid color with m colors, with a given set of m colors. are determined, no such color exists. If it is not possible with the given m number of colors, we say that it is not possible to color the vertices. Okay. If we cannot color with the given m number of colors, we say that it is impossible to determine the color of the vertices. Okay. Thank you.